Okay, greetings and welcome to my YouTube channel. My name is Pilani. I am an engineering researcher, a digital twin expert, and a founder of a company called SyncdWRLD. So on this video, I'll be taking you through some of the basics or fundamentals of digital twins. But before I proceed with the video, can you kindly hit that subscribe button and that notification bell so you are notified the next time I drop a new video. So by the end of this video, you must be able to define what is a digital twin, why do digital twins matter, the difference between digital twins and digital shadows, the elements that make up a digital twin, and then finally we'll look into a digital twin project that I have developed. So SyncdWRLD is a technology company specializing in industrial IoT and digital twin solutions. So at SyncdWRLD, we assist businesses in optimizing operations, enhancing decision-making processes, and reducing costs. So the core services that we offer at SyncdWRLD are, but not limited to, consulting, IoT and digital twin training, digital twin development, system monitoring and maintenance, and predictive maintenance. We offer these services to industries such as manufacturing, mining, energy, and construction. So what is a digital twin? So if you go online, you find multiple definitions of what is a digital twin, but in simple terms, a digital twin is a visual representation of a physical system where the data flow between the visual system and the physical system is in real time. Why do digital twins matter? Digital twins matter as they assist in optimizing efficiency. They can perform predictive maintenance using different AI techniques, thereby reducing downtime. And they also assist in enhancing the process of product design. So the more you dive into digital twins or the more you learn about digital twins, you are bound to come across the term digital shadow. So what makes these two technologies similar is that both, when they are designed with an aim of representing a physical system in the virtual world. However, that is where their similarity ends. So digital twins and digital shadows are different in that the data flow in digital shadows is unidirectional or one way from the physical system to the virtual system. While in digital twins, you have a data flow that is bidirectional or two-way. And digital twins are fully interactive systems, while digital shadows are passive monitoring systems. So digital twins are used for real-time optimization, simulation, and automation, while digital shadows are used for tracking, logging, and analysis without real-time feedback. This then makes digital twins more complex systems to design as compared to the digital shadows. So as I've mentioned, when you're developing or designing a digital twin, you must have identified the physical system that you are creating this digital twin for. And then you also need to identify the goal or the objective of your digital twin. What are you trying to achieve? Are you trying to optimize efficiency? Are you trying to reduce the bottlenecks? Are you trying to reduce downtime, right? Once the goal is clear, these are the three elements that make up a digital twin. You have hardware, being your IoT sensors and a compatible microcontroller. And then once you've set up your hardware, then you need to also identify a compatible IoT gateway and cloud where you'll be storing and processing your data. And then you need to design or develop a simulation model using softwares such as MATLAB or SIMULINK. Then once all this process is done, you integrate these three elements and then you have created what is called a digital twin. However, we have two types of digital twins. We have a physics-based digital twins, which are the digital twins that are more like complex because they are more like three-dimensional digital twins. And then we have the data-driven digital twins. These are just digital twins that deal with data that comes from the sensors. So now going into the project that I have developed. So I have developed a data-driven digital twin for a water bottling plant at the Central University of Technology, Free State in South Africa. This digital twin was for academic purposes. Before I get into the digital twin, I have a video here that just shows you how the actual water bottling plant, which is our physical system, how it actually works. So this water bottling plant produces two types of bottles, namely the 300 ml bottles and the 500 ml bottles, right? So this is to address one of the demands in the current market, which is product variety. But product variety then leads into assembly lines being more sophisticated or complex, therefore resulting in an increased cycle time. So this digital twin that I have developed is for the reduction of cycle time. So let me play the video and then we see how this water bottling plant operates. So this water bottling plant is made of 3 workstations. Station 1 being the filling station, and then we have the second station being the capping station, and the last station being the packaging station. But for the purposes of this project, my focus was on cycle time reduction, cycle time being the amount of time it takes to convert the raw materials into a complete product. Therefore, workstation number 3 was omitted from this project. So after identifying the IoT sensors and the compatible microcontroller, then these sensors were then integrated to the water bottling plant, and their data was then sent to ThinkSpeak, which is a cloud platform. So on ThinkSpeak, a channel was created with 4 fields, each field for each sensor. So this channel will then assist our model in doing, let me open the model, in doing these cycle time calculations. As you can see in our model, we have these 4 ThinkSpeak input blocks. So what these blocks basically do is that they live stream from ThinkSpeak from this channel. So each block for each field, and then it then uses the data from these sensors as inputs to our model. Then this model then calculates cycle time. So this cycle time will then be compared to the cycle time of a digital schedule. So a digital schedule is basically the same model, just that with no real-time inputs. So in a digital schedule, the inputs are manually declared as variables, and then cycle time is calculated. So if we can go back to the presentation. So here we have this digital twin dashboard. So this dashboard basically gives the operator a more like simplified visualization. As you can see from this dashboard, the operator can tell how many bottles have been completed, where is the water level and the flow rate, so they can actually even do the refilling of the tank while production is ongoing. So the 2 models, the digital twin and the digital schedule, were developed, and they were given the same customer orders to use as inputs. So there were 6 customers in total, from customer A to F, and as you can see, the total cycle time show that the digital twin was able to have calculated a cycle time that is much lesser as compared to the digital shadow. So you can see here in the performance evaluation and model validation, so you can see that in the first two orders, order A and B, both these models were performing the same. But as soon as the water level dropped below 75%, the digital twin started outperforming the digital shadow. This is because the digital shadow doesn't have the luxury of real-time data or live inputs. So in digital shadow, you have production pauses just to give the operator some refilling time, while in digital twins, there's no need because the operator can actually do the refilling while production is ongoing, as they have that digital twin dashboard which is in real time. So in all, the digital twin was able to reduce the cycle time by about 19% on average as compared to the digital shadow. So thank you very much for getting this far. Thank you for watching the video. Kindly subscribe again if you haven't subscribed. Share the video, and I will drop the link to my LinkedIn profile should you be interested in consulting. As I've mentioned, we offer different services: consulting, IoT and digital twin training. So if you want to optimize or reduce costs in your business, you can reach to me on LinkedIn. Thank you.